Okay guys, in this video we are going to discuss about example for first order RSM. We have first order and also second order RSM. You know what is RSM? Response surface method or response surface design. So in this we are discussing about first order RSM method. So example, a chemical engineer is interested in determining the operating conditions that maximize the yield of a process. Okay, so they are clearly giving the statement that the purpose of the chemical engineer is to maximize the yield of the process. Two control variables influence process yield. What are the two control variables? Reaction time and reaction temperature. The engineer is currently operating the process with a reaction time of 35 minutes and a temperature of 155 degree Fahrenheit, which results in yields of around 40%. So they are getting yield, the chemical engineer getting yield under the current operating condition of operating time is reaction time is 35 and temperature reaction temperature is 155 degree Fahrenheit. For that they are getting 40% of responses or output or efficiency or yield we can consider, and they want to maximize that 40%. So current operating condition they given, then they want to maximize that yield also they are telling. So because it is unlikely that this region contains the optimum. See, if it's a first order model and applies the method of steepest ascent, even though they are not giving this, because it's like a region on steepest ascent, or that maximize the yield, even though they are not using that spelling out that maximize or steepest ascent, by considering the yield efficiency with the term, we have to assume that it is steepest ascent method. Okay, so some of the parameters they given here, the responses also given, parameter x1 x2 factor 1 x1 and x2, and coded variable low level of x1 x2, low level of x1 and high level of x2, high level of x1 low level of x1, and high level of both x1 and x2. With that operating condition they performed something, not something, they performed the experiment and found out the responses. How this is being designed? So assuming that current operating condition is 35 and 155, they consider that one as a center point. Consider as a center point. Before and after they added a term or added values like a 35 in the sense equal 5 interval. They consider 35 with the 5 interval means in previous before 35 it's 30, next is 40. Then similar for temperature, operating temperature 155 means 5 uniform interval in the sense 150 or 160. That's what they done. 30 150, 30 160, 40 150, 40 160. Under this 4 operating conditions they done the experiment and they identified or they found the responses. Similar way, in the current operating condition they repeated the process for 5 times. Why they perform the repetition 5 times? In the sense, in order to find the what is the original error percentage what they are getting. If that original error percentage is very less, in the sense no need of doing any surface response design, but error percent definitely may be high, so that's why they are going with the proposing the new points which could be able to provide the optimal responses. Okay, so how they are doing? So if it is given, the same thing is represented. Response variable current is 40%, and reaction time 35 is the current reaction time, and reaction temperature is 155 degree Fahrenheit. So it's a 2 power 2, that is 2 power k factorial design or 2 power 2 factorial design with the center points. So this is the center point is 35 and 155 is the operating condition. Then here they are considering the 5 interval. So here 30 40 and 155 150 and 60. So here is given time x1 is the time, and in here y-axis temperature as x2. So again coding or coded variable, you know very well, we need to code in terms of design of experiment. So high level is +1, low level is -1. For factor 1 and factor 2 it is given clearly. Then we need to fit that model. So we need to, what are the value we have, we need to fit that into the first order model. First order model, we know that y equal to, so these stories you kindly please read, maybe you will get understanding. The y equal to beta 0 plus beta x1, beta 1 x1 plus beta 2 x2 plus dot 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 plus error. So here beta 1, beta 0, beta 2 we need to find. So how to find beta 1, sorry, beta 0? Beta 0 is the average of all y observations. So what are all the y observation we have from the table? We have all these values like 39.3 plus 40 plus 40.9 dot 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 40 plus 6. So all these values average will be considered as a beta 0. That is what will be the first term in your first order model. Beta 0 we can able to calculate from the average of all the y responses. Then beta 1 and beta 2, like a factor 1 and factor 2. In factorial design, how we calculated? So factor 1 in the sense high level of factor 1's response value summation by 2 minus low level of the same thing, right? So same thing. So here x1. So for factor 1, beta 1 belongs to x1. So 40 plus 40.9 plus 41.5. 40.9 plus 41.5, like a x1 factor 1 with high level. Then next other two terms, 40 and 39.3. 40 and 39.3, yeah, 40 and 39.3. So high level and low level. High level, then beta 2 in the sense for factor 2, high level of factor 2 where it is available, 40 and 41.5 means in factor 2 high levels will be there. Where is factor 2? This is the factor 2. Where is the high level? So here high level is 1, here also 1. So 40 and 41.5, that is what they used. 40 and 41.5 minus the next value. With that they are calculating the beta 1 and beta 2. See 1 by 2 of the effect of x1, 1 by 2 of effect of x2. Here effect of x1 and x2 we need to contrast. I think it's remember you have to, you might have to know in factorial design means contrast. So we can able to calculate that with this beta 1 and beta 2 calculated. When we substitute this beta 0, beta 1, beta 2, we can able to frame the first order model. So now we need to understand whether the first order model is fit or it is giving too much of error. We need to go for second order model by adding any square root or quadratic equations and all. So first we need to understand this, we need to frame this equation first order model with the inputs data what we are having. Okay, now how we can able to check whether the first order model fitted or not? We have to check few things. What are the steps? 3 steps are main. We need to estimate the error based on the center point observation method. We need to understand, we need to calculate the error percentage, and we need to test of interaction. Here which term is interaction? Here beta 1 2, because beta 1, beta 2, beta 0 we already calculated. Beta 1 2 we are not calculated because beta 1 2 is the interaction effect. So we need to test the interaction whether beta 1 2 is significant or not. Third step is test of quadratic effects. So here we are adding like a beta 1 plus beta 1 2, we are adding one more term, quadratic term, beta 1 1 plus beta 1 2 is significant or not. The summation of beta 1 1 plus beta 1 2 is significant or not, we have to. So 3 main steps are there. One is estimate the error based on center point observation. Second, the test of interaction, whether beta 1 2 significant or not, interaction. The test of quadratic, like a beta 1 1 plus beta 1 2 is significant or not, we have to check. If step 2 and 3 is equal to 0, then we can say the first order model is fit. If these 2 steps are giving 0 or non-significant value, very very smaller value we are getting from that beta 1 for beta 1 2 and for beta 1 1 plus beta 2 2, if we are getting very negligible value or non-significant value or equal to 0, in the sense we can say the first order model which we designed is fine. If not, we have to analyze further. Okay, this is what the basic steps we need to remember for solving the first order model. Then how to estimate the error term based on the central point of observation. So here error equal to sum of squares of all the values by response minus squares of sums of all the value. So here we have 5 values, here 4 values. So here 1, 2, 3, 4, 5. So where is that values? All these 5 values under the current operating condition, all these 5 values square, individually square, then sum of all this value like a 30.9, 40, 40.9, 41.5. Sum of all will be 202.3 and its whole square. That is what it's calculated here. 202.3 whole square divided by 5. 5 in the sense what? All together, because this is all 1 and this is 4 is separate, so all together 4 divided by 4, n minus 1, 5 minus 1, 4. With that we can able to calculate 0.0430, that is what error percentage. That error is what? Mean square error, MSE. This is what. So we don't know whether it's significant or non-significant or it's very minimal. We need to understand further. So now second step, first we calculated the error. So I hope you guys remember how to calculate the error. Second is to calculate the test of interaction effect. So in that I said beta 1 2 is the interaction. So we need to check how whether that interaction effect is significant or not. If it is not significant or less than it's very closer to 0, in the sense we can accept that we can say that the model, first order model, is fit. So how to calculate the beta 1 1? So this is the test of interaction estimate. So in that test of interaction, again I am repeating here, beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 1 2 x1 x2. This is beta 1 2 is significant or not, we need to calculate. So here hypothesis is beta 1 2 equal to 0. If it is equal to 0, in the sense what does that mean? Hypothesis equal to 0 means null hypothesis what? All the means are equal, generally we used to say, right? Here beta 1 2 equal to 0, in the sense what? First order model is fit. If we reject that null hypothesis, in the sense we should accept the alternate hypothesis. What is the alternate hypothesis? H1 will be beta 1 2 not equal to 0. So if it is not equal to 0, in the sense what? The model is not fit, so we need to do the further analysis. That's it. So beta 1 2 can be estimated from the factorial points. So interaction is what? Half of the average of 39.3 plus, so this one 39.3 plus 41.5, the corner points, minus average of these two will be giving the interaction, because we are calculating the interaction. Why the cross product? For understanding the interaction. Or another way also we can able to, either this way we can calculate the interaction, or another term also we can able to find the interaction. Again 41.5 plus 39.3 minus this and this. Anyway we can able to calculate the interaction with the value interaction is coming minus 0.025. That is the beta 1 2 value. Whether it's a significant or not, we need to find. So once we calculate the interaction, so two interaction are there, so degrees of freedom will be 1. So mean square error which we calculated from the step 1 is 0.0430. For that degrees of freedom is 4. For interaction, since we have two factor, interaction will be 1. So degrees of freedom for the interaction is 1. Degrees of freedom for the whole is the 4. So we have to know whether interaction is significant or not. Hence we have to compare the interaction with the mean square error. How to compare the mean square error? In this way. So sums of squares of x1 x2 divided by degrees of freedom divided by MSE. So here minus 0.1 whole square divided by 4 and 0.0430 equal to some value. We are getting this value. So if which is small, insignificant or negligible, this value is very small, the f value is very small, so we can say that the model is fit. Okay. Then next step is to find quadratic effects, that is beta 1 1 plus beta 1 2, whether it's a significant or not. Okay. So for that we need to consider some of the concepts here. here beta 1 1 plus beta 1 2 equal to y of f minus y of c. So what is that? Response at factorial points and response at the center point. So response at the factorial point, this is response at the factorial points minus response at the center point. So average of this we can have. So by doing this difference we can able to get minus 0.035. So here hypothesis will be what? That quadratic effects of beta 1 1 plus beta 1 2 equal to 0 means hypothesis, null hypothesis. If not equal to 0 means reject that, and alternate hypothesis we can able to accept. Then we need to calculate the sums of squares of pure quadratic. So how to calculate the sums of squares of pure quadratic? In the sense nf into nc. Nf means number of points or number of values in factorial points, and a number of observation in the center point. That is what nf nc. So in factorial points or factorial portion we have 4, and in nc we have 5 repetitions, so 5. So this y of f minus y of c whole square, that is what we done, minus 0.035, and 4 into 5 divided by 4 by 5 will be giving 0.0027. So with this we need to calculate the f value for test for quadratic. F value for test for quadratic will be sums of squares of pure quadratic divided by summation square, means mean square error value, that is we calculated from the previous step, 0.0430, that will be giving. So here 0.063 also. Usually in f value, maybe you remember in ANOVA when we are calculating f values will be coming 20, 30, 14, 15 like that, but here is coming like 0.0. In previous steps also we got 0.058, which is very negligible or insufficient, significant. Similarly in this while calculating quadratic effect also, the f value is coming like a 0.063, which is also small. Hence there is no indication of a pure quadratic effect. So quadratic effect not there, interaction effect not there, hence the first order model is fit. So this, once we decided, we need to make this ANOVA table. Maybe making ANOVA table is not complicated for you guys. All the terms which we calculated needs to be tabulated here. So we calculated interaction value 0.025, we calculated 0.0027 also we calculated. So 0.0027 we calculated sums of squares of value. Then again previous value also we calculated sums of squares value. Everything we calculated from the previous steps. Just we are going to place it over here. Then summation of all this will be giving 0.1772. Once we have all this value, we know how to calculate the sums of squares of total. So error total we can. So sums of squares of total will be what? Individual values, square minus all this whole square divided by how many number of factors. By doing that, sums of squares of total we can able to get this 3.0022 we can able to get. So once we have this value, all other values we are having, by from this if we are subtracting all, we can able to get the sums of squares of model. So degrees of freedom also we know, and for residual also we know all this. Once we need to know the degrees of freedom, so this divided by this will be giving the mean square value, this divided by this will give this mean square value. Similarly each and every time. Then from this value, from 1.4125 divided by the residual value 0.02953, if we do, we can able to get the f value, that is significant. The p value is significant, but other values is non-significant. So how to check 47.83? We need to refer the table. So for the degrees of freedom 2,6, if we check, it is coming some, it definitely will come f value, some f value. That f value is the critical value, this f value is calculated value. Definitely this f value is greater than the value from the table, so we can say that it's a significant. But other terms f value which is calculated is very less, so we can say it's a non-significant. Okay, then we can say that the model is fit. Okay, hence we can say beta 0 plus beta 1 x1 plus beta 2 x2 is the fit one. However, we need to ensure whether the parameters beta 1 and beta 2 is significant. Okay, by doing test of parameters estimates. Some other further steps also there. For that we need to identify the variations beta I, variation of beta I, that is V, variation means variation of beta I equal to mean square error divided by 4. So here mean square error, if we want to calculate, in the sense we need to calculate the sum of square. So if we want to calculate the sum of squares of error equal to root of mean square error divided by 4, all the value we know, this is what 0.1. So this 0.1 only we substituted. I hope you might remember from where we substituted the 0.1. 0.1. How we calculated 0.1? It should be, this step needs to be in the front. So S of E is 0.1 from this step. So if we if we know this 0.1 value, and if we are comparing that 0.1 with our previous steps, this model which we developed, here beta value, beta 1 value, beta 2 value, compare these two. Here 0.775, but here 0.325, but here that E value is 0.1. This big difference are there, significant difference are there. So we can say that the first order model is acceptable. Okay, so once we understood the first order model is acceptable, maybe we need to go for optimization, or we need to find the next level to improve the surface, improve the responses. So in that case, to move away from the design center from this point, we need to go with the steepest ascent, right? So as I said, so current operating condition, that operating condition is coded. Here you need to calculate the changes in x1 value and changes in the x2 value. For that we have the equation delta. So see, so here we would move 0 point, because beta 1 is 0.775 and x2 is beta 2 is 0.325, right? If it is the steepest ascent, the current operating condition is x1 equal to 0, x2 is equal to 0. What is the slope? Because it's linearly varying. What is the slope in the sense? 0.325 divided by 0.775. By doing that, and also uniform interval, if we are moving, in the sense we need to understand what is the next step. So that is what we need to consider. Where this point, x1 equal to this epsilon 1 minus 35 divided by 5, epsilon 2 minus 155 by 5. By 5 is what the interval we consider. So that you should recollect now. Oh, okay. Oh my God. Okay. By doing this, so now delta x1 equal to 1. The step size for the x1 equal to 1. Delta x2 will be the relationship between the slope. The slope only be. So if we calculate the relationship, we have the 0.42. So for x1 we have a 1, and for x2 we have a 0.42. So that is the step values. Okay, step values we understood from this beta 1, beta 2. So initial condition, and in original condition with 1 and 2, 40 and so 5 and 2 is there. Yes, 1 and 2 in the sense this is 5 and 2. So 5 and 2, if we have a 5 and 2 in the sense, it will be added like a 40 and 157, and here we are increasing into 2 times the term, 45 and 159, 50 and 161, 55 and 163, like goes on. So under this operating condition, we need to do the experimentation 1, 2, 3, all the experimentation. We are, by increasing these values, we need to do all the responses. We need to document. At particular point of time, we could able to see that the responses value started decreasing. We should not stop immediately. At least 1 or 2 trials we need to do more. So after doing that, we could able to see that here is the increasing trend, up to here is only increasing trend. After the responses getting decreased. The current operating condition is different actually. What was the current operating condition? 35 and 155. But after adding all the optimizing all the input variables, or adding this, At the 85 and 175 operating condition, we are getting 80.3. The original was 40 percentage. Now we are getting the responses is 80.3. So behind which is reducing. So here itself we have to stop, and we can say that this is the optimal condition where we could able to what to say, we could able to stop, we could able to stop the things. Okay, then it's represented. See, each step 1 2 3 4 5 up to here it is getting increased after this started decreasing. In graphical view also, the current operating condition to the next operating condition, it is stopped. So what should be done again? If you consider this is also one of the new method, new coordinates in this condition, like a condition 85 and 175 as the current operating condition, with this like values like 80 90 and 170 and 80, again we need to do the same process, and again we need to make this, then we need to understand whether interaction is there, quadratic effects are there, is there significant or not, then we need to. So again they done that, but the values what they got is not good enough, so they'll say they think the previous step what we calculated is the better response value we are getting. So this is the procedure we need to follow. Okay, what are the steps we followed? We need to follow 3 steps mainly. First step, need to calculate the beta 0, beta 1, beta 2, and once we calculate the beta 1 beta 2 and all, beta 1 2 and beta 1 1 plus beta 1 2 summation we need to calculate, that is estimate the error, test of interaction, test of quadratic effects, whether it's significant or not. If we want to calculate the significant or not, we need to calculate the f value. If we need a f value, means we need a degrees of freedom, we needed sums of squares of errors, we need to calculate. How to calculate the sums of squares of error or mean square error? For first step it is the procedure, and second step like interaction means interaction effect, again interaction means this corner and this corner values only we can able to calculate. Once that value is there, degrees of freedom, you know, we can able to get the f value. Once we have the f value, then for the pure quadratic effect, with the f equal to pure quadratic effect divided by sums of squares of error, this is calculated in the first step, and sums of squares of error can be calculated using this. Here NF and NC. NF is the factorial portions value, NC is the center points number of observation. In center portion we done 5 repetition, in factorial portion 4, so 4 into 5, this values 40.425 minus 40.6, this is average of center points 5 value, and FC is the average of all 4 points. So that we will be getting the beta 1 1 plus beta 1 2, substitute that in the f, so that we can say it's a f value. So f value of test of quadratic also we know, f of what to say interaction also we know. Then we need to make a f table. In the f table, compare the f table with the degrees of freedom. If that calculator value is the value is lesser than the critical, as not significant, we can accept. So we could be able to accept that. Okay, so maybe it's looks like a big procedure, but kindly go through the presentation file once. And also please read the textbook which I said. Maybe you guys will get the better understanding more. Okay, so I'll be continuing the next video with second order RSM model. Okay, thank you.